So actually, before we start, why don't we just have the two of you comment on the InnoFab idea that Antonio presented and just kick us off with that innovative site there in Barcelona.
I can start. I think Tony's spot on. The infrastructure is one of the biggest requirements for a hardware process scale-up like us. And to the point that Jose made earlier on the panel, you have to demonstrate a lot as a startup in the actual industrial environment. That is what our customers are telling us. It is about matching the industry standards around advanced packaging, from features all the way to signal integrity and electromigration. And a lot of these tests cannot be done by us without a multi-million-dollar investment. So we started talking to InnoFab already actually earlier this year about an opportunity of finding some space. And I think the transition from low TRL and high TRL is maybe something that we didn't talk about in the yesterday's discussion, and that's a very important one because we can talk about the valley of death and all of it, but some of the applications that there's a lot of investment in, they're quite low TRL and low commercial readiness level as well. So to bridge that gap and make sure that you create, as we mentioned, clusters around certain problems, bring customer feedback into it is very important, but also just having the infrastructure to go from TRL 1 to 3 to 6, which is probably one of the hardest, that's very much needed.
Great. Francisco,
well,
any
I
further?
completely agree. I think that there is a mismatch between what is research and industry. So there is a low TRL in academia, so you usually go to TRL 3, 4 maximum, but then there is a gap until you have a product. And so before that, having a prototype. So you need to have something in the middle that is a real pilot line that goes from a low TRL to pre-commercialization or commercialization. So this is much needed, actually. Not only one, but probably more than one pilot line across Europe.
So, Antonio, if we step back a little bit from the InnoFab and look at sort of general principles about companies that manage to scale, are there lessons for the European ecosystem there that we could sort of number 1, 2, 3?
Yes, as a matter of fact, there are some exceptions, even in Europe. I like to mention, for instance, the Finnish company IQM, which is quite advanced in the computing space.
So say it again, because I wasn't familiar.
IQM
okay.
is a Finnish quantum computing company, right, which managed, indeed, to convince European Union to get them really 400 million for such a line, and which is being built. Another exception is a company in Germany called Black Semiconductors. So those companies are have to be the top-notch, at least from the view of the investors and public administration, in order to get a chance to get these kind of investments to build their own infrastructure. But as I said, this is more the exception to the rule. And there are many very good companies which are still struggling. Also companies with excellent products and ideas and technologies. And I guess if we would also add more focus to this Lab-to-Fab, also from a funding perspective, or maybe a combination of public and private funding, we would get more of these top 1, top 2 level companies into through the valley, yeah? And we need that, definitively. We need really new champions, especially in Europe, in these new market segments.
So, Francisco, let me turn to you and your own experience with Spark. What was the key challenge in making a move? Or maybe you have 2 or 3, but again, it would be nice to sort of simplify the message if we can.
Well, first of all, I would like to say what is Spark first.
Yeah,
for those that do not know what we are going to do there. So we are a 3-5 pure play foundry located in northwest Spain. And we are going to produce 3 different compounds. So indium phosphide, gallium arsenide, gallium nitride. And in gallium nitride, everything for photonics, but specifically gallium nitride for electronics too. So what is the key challenge? So it would be easier to say what are what is the non-challenge here to do this thing in northwest Spain. Actually, Spain has no tradition at all in semiconductors, you all know this, but specifically in northwest Spain. So, but anyway, this could be a long conversation, but apart from that, going back to the question, I can tell you three different key challenges here. First is to position the company inside the national ecosystem and inside the European ecosystem. So we need to position yourself, differentiate the company, and
do you wish there was greater alignment between the national ecosystem and the European ecosystem?
there is a difference.
Yeah. Do you wish there were greater alignment between those two?
Sure, and there is
Yeah,
an
so
alignment
this
in
is-
photonics. I think that at least in photonics, everybody, I mean, the number of people working in photonics is reduced, so probably everybody knows we are always in the same conferences, events, so we have lots of meetings, so I think that it's a small team of people. So in that sense, the ecosystem in photonics could be produced, and we can discuss this. In the microelectronics, I don't know, because that is not my field. So I think this is one thing, position the company. The second one is, as a startup, partly a spin-off from the university, to stop thinking on research. I mean, it's a company, so we must talk about yield, repeatability, good dies, so this type of things, and stop thinking on doing research. A production facility is not for research. Then we have very good, the PIX Europe pilot line, we also will have InnoFab, so this is not for research. And the third point is building trust. We must give a clear message about our capabilities to do what we want to do. But in this case, the public-private alliance that we have with investment in this A round that we have this year with the Ministry of Digital Transformation and Civil Service and the majority shareholder, that is Indra Group, that gave us credibility to what we are doing now. So for me, those are the three key points.
I think this issue of trust is one I'd love to hear the two of you jump in on too, because it's so key. Jekaterina, do you have thoughts about that process?
Absolutely. It's all about trust in this industry as one of the probably the most risk-averse industries. Talking about a technology that is slightly different, that does not talk about incrementalism. It talks about step change. It talks about disruption, thinking outside the box. It was our super strength and a super weakness at the same time, because when you talk to customers, it is off-putting at first, and they need to really understand the detail of how it works to believe it, and then you just bring a lot of data on the actual technology in order to build that trust. And a lot of it is around data, and then some of it is also personal relationship building. But in my experience, once you have a single big customer that really takes that leap of faith, and we got extremely lucky early in our journey, quite early, 2023, we got a pretty big project with our North American equipment maker who's on the top of their game, and they gave us a project to validate our technology in the advanced packaging space. And that was a step change once we've not only kind of completed the project, but also exceeded their expectations on certain metrics. That was a really incredible brand building, accelerating momentum for us, because then all of a sudden we were, meeting the standards and exceeding some standards that the industry knows and can wrap their head around. It became this tangible trust building tool that we've talked to everyone about, because we were so proud that we're now actually playing on this level.
On that level, right.
Yeah,
so made a leap.
But before that, we can talk about the hundreds of meetings that we went to, and we've shown some real data, real SEM images of structures, and people were very cautious, and rightfully so. It is about yield, it is about reliability,
Right.
good die, and we're not at that stage because we're still TRL level 6.
Right.
So it's a really vulnerable place.
Right.
And it is about the leap of faith. It doesn't matter how
Right.
much trust you build when you're early stage.
So you're nodding there. I'm
Absolutely. In
thinking
fact,
about
I worked
InnoFab.
also many years, and there is nothing more risk-averse, as you said, like a fab manager.
Right.
So every change, in fact, Philippe was telling that today, making chips in general, not only the advanced chips, but in general chips, is extremely complex. And since you have many steps, every step has to yield close to 100% in order to have a 100% at the end, or a 90% maybe. And this is something, every innovation means risk and disruption. And that is one of, you have even a bigger issue because you are bringing something to the game which is for the technology which is mainstream today. And that's even a higher entry barrier. I was talking in my talk about more the new stuff, which may have a little bit more time to evolve and mature, but the essence is the same. You are never going to become a player if you are not able to provide data. And these pilot lines provide the environment to get this data and this maturation. As a matter of fact, I want to say this InnoFab concept is having so much success that we are getting not only Spanish startups, startups from all over Europe, even from Australia, to come to Barcelona. And
not just us.
and it's not you in this case, it's another one. But there's a queue, a really long queue, to get a space in this clean room because they are totally eager to finally get access to industrial equipment and to also cooperate. So we have even one equipment manufacturer which is testing a very advanced lithography system there, which is going to offer their services to the other startups which are there testing new stuff. And that's a very nice way to innovate, in fact.
So how long will we know whether InnoFab is a model for other InnoFab Mark II around the place? How long?
I start to see some very nice activities in Europe.
Yeah.
I like to highlight VTT in Helsinki, in Finland, which are also thinking along the same. Also in Copenhagen, there is also a clean room that is starting to open up for this kind of fab spaces. I see also other ideas from. So this seems to be, at least for the hardware focused startup scale-ups, a very good recipe. Unfortunately, I have to say nothing against IMEX, Cialetti, or the Fraunhofers, but the difference is they are very much focused on the leading edge clients because that's the biggest business for them. And yes, they are also offering MPVs, so multi-product wafers, test wafers for smaller companies, but they also take long, and also they are not cheap. So that's what I hear from the startups where I'm invested. And so we will also need to show agility in these lines. So
right.
That's not a given.
Right. So Jekaterina, I want to come back into your own area of specialty in advanced packaging. And as that's become more complex, what's the role for additive packaging?
Well, I think additive, it can be easily misunderstood as something to do with 3D printing. So that's definitely, there's definitely a very big distinction. But additive in a sense of the word just means building material as opposed to removing material. So I think there's some really interesting opportunities in the additive space that are being investigated right now, mainly for fast turnaround, chiplet level innovation, which is needed. And I think accelerating the go-to-market strategies through the use of various additive technologies, not just ours. So we come at it from a perspective of our stamps are very easy to build. You use conventional lithography, you can modify your design on the fly, and just imagine having access to a technology where you don't have to build a mask to build something that's on the leading edge of the advanced package. And then all of a sudden you can actually bring chiplets together to create something unique that nobody else usually has an access to, unless you're building masks in-house, which of course takes a lot of infrastructure. So I see additive mostly playing a role in accelerating some of the technologies that are currently emerging, probably those earlier TRL opportunities that we talked about. Now there is the flip side. When you use additive technologies that are not scalable, you will essentially need to redevelop the stack of materials to transition to high volume manufacturing, which semiconductors is the is a game of scale. You really need to get to scale in order to make substantial profits. So unless you create your technology using a stack that is actually scalable in the future, it's going to be very challenging. In fact, when I was in my first startup building sensors in Germany, that was the biggest challenge we faced. We created a prototype. It worked reasonably well enough to convince Samsung and LG to give us a project around scale-up. And then we realized that scaling using the same materials wasn't possible, and it became my job to then take that prototype and turn it into scalable production at cost, so less than €1 per sensor, which had several devices embedded into it. Back in 2015, there was no technology that will allow you to do that. Clean room fabrication was not feasible due to cost, and other printed electronics technologies in the roll-to-roll space, for example, they were still so emerging that you basically had to create a breakthrough in order to redevelop the same exact sensor that we knew already in the lab was working. So unfortunately, long story short, the startup failed, the scale-up journey failed. Yeah. That did inspire Sienta, but again, that speaks to the value of having that infrastructure where you could actually start building with high TRL, mass manufacturing, cost effectiveness, and revenue model in mind. You don't have to have all of the parts of the puzzle yet, but you need to have that high volume manufacturing ambition and start working backwards. Are there technologies that I can use today as part of, for example, InnoFab, that later on will be the same technologies I will use through TSMC or someone else? Right. That I think is the important lens that we need to use when we talk about additive.
So Francisco, we talked a lot about trust and now scalability we're talking about, but there's also certification, reliability, access to equipment. Can you sort of order those when you're thinking about the industrialization process, or address the others that we...
Well, yes, I will try to.
Yes, a big question.
Based on my own experience, I think that there are, again, what is not a challenge here, what is not a bottleneck here. Right. So there are several bottlenecks along the way, but the first one probably is the most based on the physical side. I think that you need to have the tools, the land, the money, the human resources. You need to have everything that is more related to the physical aspect of the thing. And here again, I would like to make a question on the other panel related to human resources. The big elephant here in the places in the room is, since 2015, 2012, something like that, women are isolating themselves from STEM science, so this is a fact. But nowadays, this happens to young people. So if, I don't know what is the answer for that, but of course, if we
So we need women and young people.
Yeah. Now, it was women now, but now it's everybody. So then we will have a problem there, because if, as someone said in the question, if 50% or more than 50% of the population refuse to go to STEM, then we will have a problem in the end. And we have a problem because we don't need enough fab. We need not only master students, big scientists or whatever, we need technicians. So we need people that actually work with the machine, with the equipment. And we need a training program for that, because there will be lots of fabs here during next years, and unless we prepare a training program for technicians, we will fight against each other to compete for the best technicians. So this is something that will happen. Okay, so first of all, physical thing. Second one, for us, is no longer, the second phase could be no longer, do you have the tools, do you have the equipment, is, do you have a process, do you have a stable process, do you have a product in the end that is, that has value for the customer in the end? So this is the second one. And probably a third one is the most important, that is scalability. Can you scale up your company if at some point, now with CHIPS Act 2.0, and then also with the numbers, figures that we saw here, going from 630 billion to 1.3 trillion AI data centers or whatever, are you ready to scale up? So do you have muscle enough to do that. So those are the three bottlenecks.
So, Antonio, talk to me a little bit more about this process of going from prototype. Lots of hardware companies, right, produce good prototypes, but never actually move to a product. Where's the biggest barrier there?
So I think the majority of the startups are typically spin-offs from the university. And they have learned to make chips at the lab of their institutes.
Right.
And in semiconductors, the processes that you're running on a lab are typically different than what you are running in a fab. So you are using a lot of wet etching, you are using a lot of metal evaporation, you are using processes which are not available in large factories. In large factories, you tend to do dry etching because you have a better control over the process. You are using sputtering or atomic level deposition because this is what you need also for yielding. At a lab, you need maybe one good working device at the end of the day, in an extreme case, that you can show and not only make a paper, but even promote. I see you agreeing with me.
Yes, I'm looking forward to your comments.
Yeah, and so now the point is, this is what you have. And then somebody's asking, oh, give me 100 or 1,000 or 10,000 of them. Then you stand there, oh, my goodness, how do I do that? And then you start looking around. And then, indeed, that's where we're trying to solve. And of course, also these large foundries are not there to redevelop your process. This is something they don't want to do. Now, give me one thing that I can do with my machines, because I'm not going to put a kind of lab-level machine in my factory for you. And that's exactly the issue we're trying to solve. And then you need really technology experts or process experts, which can tell you, you're doing this metal or this, dielectric. For the high TRL solution, I will develop with you something else, which is going to be as good as, or even better, and then it's going to be scalable, typically on full wafers, and then integratable with the rest of the stack. Also, lithography is a good example. You are using mask aligners, so manual things you're kind of aligning. No. You go to an ASML scanner, and everything goes automatic. So you need special masks. So it's a very different world. And this translation is what is needed to make really a product.
Jekaterina, you add your comment, but also let's open already to comments from the floor. I can see Dongmin has a question there, but did you want to quickly follow up on what Antonio said?
I just agree with Tony, and I think the other thing that startups are really good at is focusing. So if your strength is process development, and you can build your strengths internally at the university and translate it to high-volume manufacturing, that's a fantastic recipe for success. But I think the challenges are exactly as you pinpointed. The fact that process development, on average, takes about 6 months. So, and you will have to redevelop your process as you translate it to different materials, different applications. So I think oftentimes that element maybe gets lost in translation as well.
No, I would like to point out something.
Okay, and then we'll...
Just one second, because in our case it's different because we don't have any product in the end, we don't have any process to show. We are going to be pure play, so for us, we are going to develop something for the customer that has the knowledge of the process. So in our case, I cannot give any